Thank you for joining this talk. It's about machine learning and Kubernetes and cloud-native machine learning and how everything fits together and how can we democratize machine learning and make sure that the power of machine learning is available to the masses, right? So, first of all, how many people know Kubernetes around here? Okay, I was expecting that. Machine learning, awesome. So we're gonna have some fun together. Little agenda. So something about me, because I like to talk about me. Something about machine learning, why I think it's gonna change the world, and why I think cloud native and Kubernetes are changing the world right now, and how to perform scalable machine learning in the cloud. Something. Anyway, so. My name is Alessandro, I'm Italian, 42, almost 43. So I'm an ambassador for the Cloud Native Computing Foundation, which is the foundation, is a daughter foundation of the Linux Foundation, manages all the cloud native projects like Kubernetes, Prometheus, etcd, and so on and so forth. I happen to work at Microsoft. I have many hats. Today I probably wear both of them because I do love Kubernetes, so I'm going to talk about that on behalf of the Cloud Native Foundation, but I'm also going to talk a bit about why I think Microsoft is a platform to perform these things. My other job or passion is organizing communities, so I run the Amsterdam Cloud Native and Kubernetes meetup. We have a meetup tonight. There's a little waiting list. It's in Amsterdam. I'm an alumni of University of Amsterdam. That's why I moved here. I have a PhD, almost a PhD in chemistry. And I'm part of that, which is the Cloud Appreciation Society, which is not the cloud you are thinking is the actual clouds in the sky. It's a society of people that like to watch clouds because there is no reason, but because they are beautiful and because they make us feel humble and connected to nature. But I would like to speak about that if you're interested. So, Cloud Native Computing Foundation, let me spend 5 minutes on it. So it's one of the most successful foundation to manage open source projects out there. I'm lucky to be an ambassador, one of the 60 plus ambassadors in the world. 47,000 people. That's the largest development team you can ever find on the planet. There's more than 90 people attending the meetups. KubeCon, have you ever been to KubeCon? It's the most amazing conference ever. Last time, December in Seattle, there were 8,000 people. Just 2 years before, there were not even 1,000, and last time there were 2,000 people on the waiting list. So if you ever consider going to KubeCon, get your ticket early. Cloud Native Foundation is, of course, is a non-for-profit, so it's funded completely by the donation of the members. Most of the members, there are more than 69 companies. And companies means, among those most of them are end users, so people using Cloud Native projects and software daily in their life. Companies making money out of it, or using open source cloud native software to run their business. These are partners, so if you have enough engineers on your payroll that have a CKA, so Certified Cloud Native Administrator, or CKAD, Certified Cloud Native Application Developer, then you can get the status of Kubernetes partner. So you can be really part of the community, helping spreading the word, helping fostering the open source cloud native software. But what software is that? These are the 5 graduated projects, so the ones that have been running for the longest time. They are very stable, and they are the backbone of every cloud native software architecture out there. Of course, most of you may know Kubernetes and Prometheus, Envoy. Maybe you don't know Envoy directly, but you've been using it a lot because it's part of Istio. Many service meshes are based on Envoy. Core DNS is also part of Kubernetes. Containerd it's actually becoming the de facto container runtime for containers, replacing Docker. Docker is dead, long-lived Docker. And the other projects are incubating, so they are still getting there, and you can see some very interesting ones like Linkerd, Elm. We're going to talk about it maybe a bit later, because how do you deploy application on Kubernetes. So I urge you to go to the CNCF website, cncf.io, check the landscape of cloud native software, because that's how modern software is built, and how modern software is quickly taking over software development. Now, machine learning. So I know there's a lot of hypes around machine learning, but it's actually, I think this is real, and we have a real chance to use this to change the world in a large sense. Of course, not only avoiding collision with cars, or improving the efficiencies of power plants, or how we perform daily tasks, but this profound sense of disruption and sense of wonder in machine learning. At least that's how I feel it. So there is something real behind all the hype and all the AI, or the scare talks about AI taking over the world. So I think we have one chance at this, saving the planet, making life on Earth finally sustainable and more and easier for more people. And I think we should use these tools that we have for that. So this is a classical example. This is how, when Google started using machine learning to control the power distribution in their data centers, you can see the immediate effect of machine learning algorithms on the efficiency. And between this and this, you can calculate how many trees and how many gallons of oil you avoid burning to power that data center, right? So there is an actual tangible effect on our lives when we use the tools that we have in the best way, right? So this is exactly, so dozens and dozens of engineers and smart people thought about how to make a data center more efficient. But in all their wisdom and all their studies, they couldn't find really what made this jump. And a machine learning algorithm, because it has almost infinite computing resource, and can look at larger and larger and even larger and getting larger data sets, can spot these micro transactions, these micro actions that you can perform to improve the efficiency, something that a human will never be able to do. So this is real, it's not some theory, and you can apply this to an ever-increasing number of problems, right? So, and I hope one day to see it applied to this problem, and I think smarter people than me are starting to use this also to make informed decisions on how to impact environment. There is one problem though, machine learning is hard, right? So I'm a chemist, right? So I did study mathematics, it wasn't my favorite topic, but machine learning is hard. So, and when something is hard, there's also a lot of people wanted to make it simple, right? So that's the whole point of this talk, that's the whole point of the efforts of Kubeflow and the community around it. So this is what society thinks we do when we talk about machine learning and AI, but actually this is what most of the time we keep doing, just writing models and wondering if the model is going to work. So this is the problem, right? So we are focusing too much on the plumbing, on the little details of writing the models, when we could use better ways to train this model at scale without bothering for the details. That's what my mom thinks I do, but I don't. Of course, so this is a classical, this from a paper from a couple of years ago. So writing machine learning code is really just a part of the picture, right? And actually, it's even the smallest part. So most of the time, we are dealing with everything else, right? So this is what we should be doing, or what we should be investing our time on, but we are encumbered by all these other things. Like I'm a wannabe data scientist, but then I have to deal with infrastructure, where to run these models, how to run them, collect the data, prune the data, make sure that the quality of the data is good, monitor everything, making sense of all the data. So everything else but machine learning, right? So everything else but using my human creativity and what we do best, right? Understanding our problems. Instead, we should do that instead of everything else. So you can decompose this problem space of machine learning into smaller problems, but each one requires some thoughts. Each one requires some brain power, right? So, and that's why we want to separate these things. So we want to make sure that data ingestion analysis happens very quickly or in the most efficient way. So we capture all the data, we transform the data in a sensible manner, validate it, splitting, and then and we build this model in a very simple and straightforward way, and the training part, so the training which actually use computing power to understand the model and how the model works, happens at scale, happens in parallel, and that's also hard for the classical like waterfall way of doing this. Right? So this, maybe if you know DevOps, this is like how before DevOps, pre-DevOps era was, software development before DevOps, right? Very waterfall. You start from the beginning, you have to go all the steps, but DevOps changed all that by increasing efficiency, by using new paradigm. And that's why Kubeflow and applying machine learning to cloud native to machine learning can improve that. And you have to think that all these parts are also done by different people, maybe people with different backgrounds, people with different skill set, different agendas, different interests, and so you should be able to provide a platform that can satisfy the needs for all these different people. So there's one problem here, that is the problem don't repeat yourself, right? So why we have to reinvent data ingestion, why we have to reinvent all these scalability problems, all the portability problems. We solved this problem already, right? So a cloud native approach to software development has all the tools we need to approach this problem from the right angle, right? So if you apply cloud native to machine learning, what you get is cloud native machine learning, right? So we're gonna talk about it once I introduce Kubernetes, which is the container orchestration framework that is clearly becoming the de facto standard for orchestrating containers at scale. Some called it the Linux of the cloud or the cloud OS. It's clearly the winner of the container orchestration works. So we are now in this peaceful time where everybody uses Kubernetes, everybody's happy about it, or maybe not, but you can always contribute to change it, to improve it, and it's spelled Kubernetes, of course. So in a nutshell, I know that most of you know Kubernetes, so this Kubernetes one slide. It's really a declarative system and a self-healing system that converge to the state that you declare. And these are the components. So my take of why Kubernetes won this orchestrator wars is because A, it's community-based, so there's no commercial entity behind it. There's the foundation, which is not non-for-profit, as compared to, you name it, Mesos, Docker, Swarm, or whatever. And second, the Kubernetes has very smart design decisions made in the very beginning. Google engineers are probably the best in the world, and I say it because even if I work at Microsoft, but those people are really smart. So when they designed Kubernetes, they thought about, for example, isolating the database from the kubelet, so nothing talks to the database, but the API manager, and having these extensibility points, right? So everything is pluggable in Kubernetes, and that's we'll see that this comes very handy later when you want to extend it, for example, to use Kubernetes as a machine learning and data ingestion platform. If you have any question about it, of course, like there's tons of information out there. You should come to KubeCon, of course, and come to the day before KubeCon. We always run the New Contributor Summit. It's a great place to learn and understand the community behind Kubernetes. So some basic concept of Kubernetes. So Kubernetes just executes your orders, as in you explain to Kubernetes how you want to run things. So you tell Kubernetes, possibly in a nice and gentle manner, so please run this deployment template for me. And no matter what, Kubernetes is going to go and make sure that reality aligns with your desired state. So it's a desired state system that aligns what's going on, what runs in your cluster with your desires. And the basic tenant, the basic concept here is a controller loop, right? So everything is a controller in Kubernetes. So whenever you talk about a service, it's a service controller. Whenever you talk about a node, there's a node controller that constantly checks. In fact, it doesn't constantly check, it doesn't poll, but more watches. That's why they chose etcd in the very beginning, because etcd lets you subscribe to keys, to part of this database. So this controller, they just watches for these events to be created or to happen, and they do something about it. And for example, in case of a pod, if a pod suddenly disappears, Kubernetes will, the pod controller of Kubernetes running inside the controller manager, detect that immediately, because all of a sudden there is no more object called pod XYZ in the database, and then remediates to the situation by creating a new pod, because it's been instructed by the deployment controller, which instructs the replica set controller to create that pod. It's very simple, but it's a very powerful idea of constantly running controller loops that watches for events and reacts to that. So that's how basically a declarative system works, and luckily, those were the design choices at the very beginning of Kubernetes. So this is the momentum. There's a huge community about it. That's I think, why this is the best place to be, the best community, and I'm proud to be part of it. Second only to the Linux kernel that had about 25 years head start. So it's catching up quite quickly. So I say that Kubernetes is extensible, and there's a new pattern arising in the last, say, year and a half, spearheaded by Red Hat and by Google, which is the pattern of operators. So at some point, about a couple of years ago, the community decided Kubernetes is great, but if we keep adding stuff, we're gonna dilute all this awesomeness into whatever vendors want to add, right? So if we let too many things in the core, then the core is going to explode, and we're going to be left like OpenStack community. I was in the OpenStack space once, and it didn't end up so well, because they let too many things diluting the core mission and the core priorities of the project. Instead, Kubernetes community came up with the concept of operator. So you are free to create new APIs and you create new objects in Kubernetes, which is the same thing, actually. So whenever you create an API, so for example, when you create an API to represent a Kafka queue, that's actually an API endpoint that you can call from the same API manager that extends the core API of Kubernetes with whatever you want, and that API is backed by an object. So you are free to extend Kubernetes as much as you like and write a controller for the object that you want to add to Kubernetes. So operatorhub.io has been just launched by Red Hat, I think, a couple of weeks ago. It's great because it's one place to check the status of all these operators, right? So CRDs are custom resource definition, so this foreign object to Kubernetes, but once you add them, they are not foreign anymore, but they just extend and expand the option of things you can do with Kubernetes. So you can use an operator to, for example, run a Spark cluster, create a Spark job or a Spark cluster inside your Kubernetes cluster. And you don't need to understand much about Spark to do it. So the operator kind of masks all the complexity of running complex workloads in Kubernetes by just giving you an abstraction. For example, there's a Prometheus server. You don't need to know how to configure it because there's an abstraction called Prometheus server in the Prometheus operator that creates it for you. And same with service monitor and other stuff. So Prometheus operator is one of the very first and very popular way to deploy Prometheus inside Kubernetes. So all this, and now we are approaching, what to do with this thing, so how this thing works. So how to use Kubernetes for data science. Little deviation into Microsoft land. So Kubernetes is awesome, and Azure is also pretty good. And we have a thing in Azure, I don't know if you know it, but it's called Azure Container Instance. I'm going to talk about it briefly later when I talk about why I think Azure and Azure Container Kubernetes Service is the best place to run machine learning models, because so Azure Container Instances are basically containers as a service, literally. So you need a container, Azure is going to run it for you, no questions asked. No need for a Kubernetes cluster, no need to spin up a VM. You pay by the second, so if it stays up for 10 seconds, you pay 10 seconds, and that's it. So Azure Container Instances are great and awesome, but they're just a building block for something bigger, right? So right after I think we GA or we preview ACI, the Kubernetes community, of course led by some very smart colleagues, engineers at Microsoft, they came up with what was called virtual kubelet, and now renaming to virtual node. So imagine, so you know Kubernetes, you have your cluster, even if it's a managed service, you don't see the master, but you do see the nodes, right? So the nodes are VMs, or can be bare metal, whatever. But imagine now that you have a virtual node that is backed by ACI. So if you don't schedule any pod on that node, your consumption is zero, null. No need to pay anything. But once you start to schedule pods, and you have ways to do it by taints and node tolerations and all sorts of mechanisms to make sure that your jobs land on ACI, you start to get built. So it's instantaneous, always available buffer or a resource pool of computing that is always there. Azure is always there, hopefully, where you can just overflow your computation into. It will make sense. It makes even more sense now that we are previewing these ACI machines. So you can schedule ACI containers, which are backed by GPUs. So you don't need to create a GPU instance for your machine learning, TensorFlow, whatever, training jobs, because you always have a GPU available for your containers in ACI. I'll come back about this later. So we know Kubernetes is great. It got all these cloud native ideas and concepts, and then they look at machine learning and say, why don't we put these two things together, and we create a machine learning platform for the masses, right? So the mission of Kubeflow is to make it easy for everyone to develop, deploy, and manage portable distributed machine learning on Kubernetes, which means that everyone, doesn't mean only the people in this room, doesn't mean only engineers in Microsoft or at Google or some data scientists in a lab code, means everybody. It means that if we can get these machine learning models in the hands of everyday people or, I don't know, electrical engineers or whoever can benefit from machine learning, and probably everybody can, it will make a better world. It will make a world where we can leverage these amazing tools and infinite computing capacity for the greater good, or hopefully not for some nefarious purpose like building better missiles or better bombs, but hey, sometimes you can't control these things. But I love to talk about it because Microsoft, Google engineers, they're coming together also to prevent that these things land in the wrong hands, but it's a different talk completely. So Kubeflow is basically a community of people, about 66 or maybe 90, about 100 people more or less. Well, it grows very fast, so it's difficult to keep track. Started by some engineers at Google, but definitely not a Google project. Like Kubernetes started at Google, but don't call it Google. It's just a community thing. So, and this community is made by data scientists, people like me, managers, or whatever. And so this community comes together to tackle big problems like machine learning together. And in practical terms, it's a bunch of things that you install on your Kubernetes cluster, and magically, or not so magically, because it's still a bit complicated to install if you don't understand KSonnet and a bunch of other things, but it's getting there. So imagine you have a Kubernetes cluster and you turn into your machine learning powerhouse or your data scientist paradise where they can just run models and they can train models until they're blue in the face. And the best part is that really like democratize means that if Kubernetes is democratizing cloud application, cloud native software development, Kubeflow is democratizing machine learning on Kubernetes. So it runs on every cloud. I started, of course, with TensorFlow, which is just one training model, but it's quickly also acquiring capabilities to use PyTorch or MXNet, or and it's also not limited to GPUs or CPUs, also TPUs and all sorts of and scales as your Kubernetes cluster scales. This is the momentum also, and this only spans like 10 months. So it's in this phase where there's a lot of development. It's maybe confusing, maybe a bit scary to get in, but it's probably like Kubernetes now it peaked a few months ago, and Kubernetes now is reaching this more stable influx of patches and pull requests, but Kubeflow is still like in the expansion phase, right? So people coming from all places come together to get this thing done, right? And it's used by, I know for sure, Uber and a bunch of other people are using it in production or very close to production. Definitely not Google, so definitely most of the developers is coming from other companies. So 3 advantages of Kubeflow, right? So composability, portability, and scalability. I'll talk about it quickly. So think about it. So we look at this and say, well, this can be decomposed and then put it back together by a tool or a platform or some by Kubeflow, in fact. So Kubeflow for now focuses on this part of the model, right? So it doesn't do data ingestion, data analysis per se. Of course, there's efforts. You've seen Pachyderm it's like Git for data, they call it, and there's a first approach to include monitoring and logging, but this is the focus of Kubeflow for now, and the focus is to make this really solid and very useful, and then add more components later on. So the focus is to build a model, train it at scale, and then serve it to your data scientists for further analysis, and then repeat the cycle as quickly as possible, right? So the problem is that with this is that you need a lot of stuff to get there, right? So not only you need to have a Kubernetes cluster, I mean, you need to run this on some hardware, right? Somewhere, maybe a cloud. You need a accelerator like a GPU, TPU. Install the drivers, install the runtime, Docker. Am I using Docker, Containerd? What's the name today? Moby, whatever. What kind of storage I'm going to use? Which framework I'm going to use, PyTorch or TensorFlow. And then the tooling is overwhelming, right? So there's a lot of things you have to care for. And it's a waste of your time. This is all, and all these problems, they're trivial individually, but taken together, it takes a lifetime to solve, right? And then you solve it for one cloud or one environment, and then you have to do it all over again if you move to another cloud. So this is a big problem. This is a big no-no in machine learning. So it's a big barrier for people to approach this. So that's why you can use Kubernetes to take care of all the nitty-gritty details of running containers at scale. You containerize everything, of course, and then Kubeflow will just take care of running this for you at scale, right? So the components are more or less, there's more stuff you can add or remove, but basically this is JupyterHub. Who knows what JupyterHub is? It's a Python-based notebook manager, and by notebook is really like a program, right? So you can, in very expressive language, it's basically English plus Python or Bash. You can express what you want to do with JupyterHub. It's amazing. It's used everywhere, and we use JupyterHub in Microsoft a lot. Then you create this model, you give it to the model training component of Kubeflow. Maybe you also can add Katib, which is a new component which is for hyperparameter optimization, so scanning multiple parameters at the same time. You serve, you monitor, and you visualize what you did with TensorBoard. You can debug with the FDBG, which is probably the component that I know less. And then, of course, you can serve this model. Seldon is a model serving platform. It's part of Kubeflow now. But these are just the basic, and these are, and I think I'm missing a few already. Okay, Sonnet, Argo is a workflow managed for Kubernetes. Not my favorite. I didn't choose it. I would choose something else. But yet, Argo is this, embodies the GitOps concept inside a workflow for Kubernetes. So GitOps is where you manage everything, your infrastructure, your data as code. So you put everything in a Git repository, and Argo will happily pull it for every pull request or every time you commit, and then applies that to your cluster. So it's the workflow that was chosen for Kubeflow. You can argue maybe not the best, but still it works very well. Ambassador is a layer 7 proxy for Kubernetes, pretty much like a very similar to, say, it's based on Envoy. It's basically a proxy. Katib, hyperparameter optimization, TensorBoard, Spark, JupyterHub, Caffe2 is another training model. Pachyderm is this Git for data. So it's I'm not so sure what exactly it is, but I know it's a data platform for Kubernetes. So you see like this machine learning data all coming together, of course, like NVIDIA. TensorRT, I think they contributed to the project. It's a way to, not so sure what it is. And then this is the new thing. It's called Kubeflow Pipelines. It's a dashboard to visualize all your experiments, all your pipelines of experiments, and it's pretty cool. Unfortunately, it runs only on Google Cloud, but we are working on making it available for different platforms as well. So that's how it works in practical terms. You solve this problem, right? So which data am I feeding my model? And that's where things like pachyderm comes handy, because you can snapshot the data and treat data like you treat Git. So making a commit to your data and use that to refer to always the same data sets. Storage and network bottlenecks. So of course, like ingesting the data is expensive in terms of bandwidth. And so you don't want to, you want to make sure that you are training the right data all the time. So, and then also things like Katib helps with the exploring this hyperparameter space. And then, scaling this to large deployments, and to scale it to multiple clouds and to multiple environments. And all this by automation, and all this, of course, in a CI/CD model makes sense, because you don't want to, you want to automate all these things. Like I'm machine learning data scientists, they're not yet taken by these ideas of CI/CD, of this automation thing. So I've seen data scientists, machine learning people really repeating things and commands all the time, or keeping like, or copy pasting the same command over again. But me I come from the DevOps, automation, Kubernetes side of things. For me, like if I have to do a thing twice, it's already one too many. So that's why I want to automate as much as I can, right? So everything has to flow from left to the right without my intervention. I want to go have a coffee with my friends while this CI/CD pipeline does the job for me. So this CI/CD pipeline is really the brain of my flow, of my machine learning platform. So summary. So I hope I spark some interest. Maybe I'll show. I don't have a demo per se, unfortunately, because there's a great demo made by my colleague about using ACI with GPU to train models at scale, but last night it broke because the ACI with GPU is preview. Something changed in the base image, and I couldn't get it work anymore. And I couldn't fix it. So well. So Kubeflow is this open source platform for machine learning on Kubernetes. So you want to do machine learning on Kubernetes? Great. I think you're better off starting with Kubeflow and contributing and looking at instead of do-it-yourself solution, right? So not a single package, is a collection of packages, but the installation is pretty straightforward, and still need this KSonnet thing, but I hope one day to get out of this KSonnet. KSonnet is a templating tool for Kubernetes, so starting from a set of files, YAML files, creates the deployment templates for Kubernetes. So all the complexity is gone now. You just have to deal with your model. So you install Kubeflow and get started on Jupyter Hub. It's multi-vendor, multi-cloud, runs on-premise, runs on Minikube, runs everywhere. And at the core is a community. So it's not a commercial problem. I'm not selling Kubeflow to you. Microsoft definitely is not selling Kubeflow. But if Kubernetes helps you get there through Kubeflow, I'm happy, because I am an ambassador for CNCF, and I work in Microsoft that, by the way, has an awesome managed Kubernetes service. And for me, it was also a way to get to understand machine learning better and actually see it in action without going crazy and installing 10,000 things on my laptop, right? So that's how you get started. Kubeflow, There's a Slack community, almost there. GitHub, and there's a great Katacoda. Katacoda is this online platform for learning, and there are great tutorials on how to get started. So where to go from here? I love communities and I love conferences where communities gather. So a big one, which is Cloud Native / KubeCon in Barcelona in May. And the one that I'm organizing, I'm making sure, please, we don't have everything ready yet. The call for paper is going to open pretty soon. The call for paper for Barcelona is closed. There's one open for China, which is in July, and the one for San Diego. San Diego is set to be 12,000 people, so also the biggest KubeCon ever. And I'm organizing a Cloud Native Day, so from the meetup, from the community. It's going to be in Amsterdam, it's going to be in June. We expect to have about 300 people. CNCF is on board, and it's going to be awesome. And soon, if you watch my Twitter or watch the news, CNCF should announce it, and I'm going to announce it on Twitter. So we're going to open the call for paper to talk and present the Cloud Native Day. That's how, I know that is not a demo, but and show, and the show, yes. Any question while I fiddle with my Mac? Oh, it's already mirroring.
Yeah, I use Google Cloud, so.
Good.
Sorry. Do you don't have any notes on the container manager?
Container manager?
Yeah, the thing you presented. Yeah, you can host your containers in a what? Is it
so ACI.
You see the master, but you see the nodes, or is it a
Yeah.
virtual node that is infinitely?
So a virtual node is a pod running in your cluster in kubesystem namespace, probably most likely. Actually, I can deploy it quickly if you bear with me, because that's where I was. That's where I trip. So, by the way, is installed by Elm. Wait a second. So, I know it's small, but I'm gonna make it smaller. No, I'm gonna make it bigger. See? So this virtual kubelet is a deployment. Yeah. A deployment that for now is 0 kube system. So wait, it's in the it's a pod that responds to the API, extends the API, and acts as a virtual kubelet. If I look now at my nodes, I have a virtual kubelet node. It wasn't there before, trust me. So this Elm install, blah, blah, blah. It made this. So this virtual kubelet node, I can describe it. And the funny thing is, because I'm using this image. Where is the image? Wait, I'm using this image of the pod, of course. This is the image. Yes. So I'm using the tag ACI GPU, which enables the virtual node to also list that there are 100 GPU at my disposal. This is my quota, basically. So I can run 100 jobs, GPU accelerated containers of TensorFlow, whatever, through Kubeflow in ACI. I pay by the second. When they're done, they're done. The job dies because the Kubeflow TF job controls this, and then it returns to me the capacity. That's it. So that's how it works. It's pretty powerful. So, and the thing is, the best part is that Visual Kubernetes is all open source. There's a thing called Fargate in AWS. Same thing, like a container as a service. And they extended Virtual Kubernetes to use Fargate. Any more questions? Because we are there. Cool. Let me thank you, the organizers. And if you want to know more about the Cloud Native Day or the meetup tonight, please go to meetup.com or come talk to me on Twitter or anywhere else. Thank you.